Hello, my name is Jenelysc Martinez and I am a sophomore. Today I will be narrating the presentation for the autonomous driving RC car slash LIDAR detection research. This is a project that we started in the spring of 2019 and have continued all throughout until today. And in this PowerPoint, I will include our research results from last semester, fall of 2019, and our research results from this semester, spring 2020. So the scope of the overall project is to develop an autonomous vehicle that can be aware of its position in a racetrack. In addition, we want this vehicle to be able to drive along other vehicles that are also autonomous and can prevent collision and avoid obstacles. So the goal of the research project is to help us understand what methods, what programs, what techniques, tools, technology we as students would need in order to develop this autonomous vehicle. Throughout past research projects and even the project this semester, we have delved into different types of technologies such as sensors or software or hardware that we would need in order to develop this model. And that's exactly what this part of the project is also about. So here's a quick overview of the project. We begin the project by utilizing the Zone Founder PyCar S model, and this is a small model vehicle that comes with a couple sensors such as an ultrasonic sensor, a line follower, and a light follower. And its most important point is that it's compatible with the Raspberry Pi, which is a small computer. And we know that if we wanted to go autonomous, we would need some sort of computer power. So the Raspberry Pi was our best option, hence why we chose it. But that brings us to our next point, and that is that the Sun Founder vehicle is very limiting. The car to work needs more connections to different sensors, and the Sun Founder comes with a hardware attached on top or a hat board, and this board can only allow one of each sensor, and it can only allow an ultrasonic sensor, a line follower, or a line follower. And since we needed more different types of sensors in order to work, such as a camera and other things, the Zone Founder became a very limited platform to utilize. Which brings us to also our next method, which is new methods to collect data that need to be developed. So throughout all the sensors we consider, we came to the conclusion that a LiDAR is an ideal candidate for any obstacle avoidance and navigations that we would love to utilize. LiDARs are very accurate and reliable in contrast to ultrasonic sensors, and they're faster than ultrasonic sensors as well. A lot of like high-end autonomous technology uses LiDAR, such as Tesla, so this became the best option for us. So here are the variables that we needed to consider. The first variable relates more to the project as of last semester, which was the non-compatible hat. The hat allows for one Sun Founder type of sensor only, as we mentioned earlier, and it's the manner that it's also built, very complicated and not flexible at all. And that brings us to our next variables for this project, which is a LiDAR. We need to find a device, a LiDAR that can be cross-platform and that can cover the ideal ranges that we're looking for. It is a race, so we're looking for ranges of more than 15 to 20 meters, something that can go there or farther. So that's something that we have to look up. Also something, as we said, cross-platform. So something that can be compatible with the Raspberry Pi and with whatever other models we need to use. There's also a need for a better understanding of our algorithm components. LiDAR sensor data can be very complicated to understand, and that's something that we need to do. We need to understand this data, we need to process it, and we need to send it out. So that is something that we have to consider as well. So here are our materials. We need the Zone Founder car kit, a microcontroller, which is the Raspberry Pi, even though it's actually a microcomputer, but that's what it's going to be utilized as. We also have the LiDAR, which is a SlamTech 360 RP LiDAR A1 model. And software-wise, we have Robo Studio for its mapping tool and the Slamware C++ SDK to build our algorithm. So here's our procedure. We began with our step 1 last semester, which was analyzing why when we connected more than one ultrasonic sensor, we could not get them both to work. So we did a thorough analysis of the board and a lot of testing, and through this was how we determined what was wrong with our board. Our step 2 was to move away from the SunFounder equipment, and that's when we decided to seek out the SlamTech RP LiDAR. So here is when we decided to test and see if it met our expectations software and hardware wise. And third step was focused on hardware control, the idea of instead of utilizing the HAD, we could directly utilize the Raspberry Pi. We managed to successfully connect several other sensors to the board, and it worked well without the HAD. And our fourth method was the hardest, which is still ongoing, and that is finding a method to transport LiDAR data from our algorithm to communicate with the actuators in the model vehicle. So here are our results. Again, this presentation is about last semester research and this research, so I may have given some of these results away throughout the presentation, but we'll still talk about them just to go into more detail. And we will begin by talking about the SunFounder model and why it's limiting. This primarily has to do with its HAD, its hardware attached on top board, and this board is physically built in a way that it cannot take up different types of sensors from the ones it can use. If we wanted to implement a LiDAR or a camera with it, it will be impossible for us, whether it's with the hardware or the software. In addition, even if we wanted to use like an ultrasonic sensor, which is the one that it came with, it's still kind of hard to implement more than one. Again, because the way the HAD is built. The SunFounder platform is also restrictive with its software. In order to implement an autonomous vehicle, we need to use machine learning and computer vision algorithms. And SunFounder comes with its own code, its own Python code, and this code is used to test motors and sensors. So this code that came with the program makes it very limiting to utilize machine learning and computer vision. Now we will move to our next result point, which is the LiDAR. Again, we chose LiDAR because we thought it was the most reliable sensor method, and we chose the SlamTech RP LiDAR 8.1, and this is because it covers a distance of 20 meters and is very affordable. I mentioned earlier that a good distance for us would be 15 to 20 meters, and the SlamTech LiDAR gives us just that. It also has a really good mapping area. It's a 360 LiDAR, so it covers a lot, and we need to get good accuracy, and this LiDAR gives that to us. Another reason why we love the LiDAR is because the SlamTech LiDAR comes with a very powerful mapping tool. This is used with the software that I mentioned in the materials, Robo Studio, and Robo Studio has a good tool that helps us keep track of real-time laser data as well as real-time coordinates, so we can know where we are and the objects that are in front of us live and keep track of those. So this tool makes it easier for a person to monitor the vehicle, to visualize the obstacles, and it's also very useful for the algorithm for machine learning and computer vision. If we have this tool, we can teach the algorithm to interpret LiDAR data. So this is very useful for us. There is an image that I will show in the next slide, but before that I will go over how the RP LiDAR is very useful with regards to software. And that is, the LiDAR is a very useful tool as a safety net. We will have computer vision as our main navigation system. And computer vision is very useful if you train a vehicle how to navigate throughout one area after it gets used to it. But if there's an object that for some reason we're not able to pick up, or it's outside of training data, a LiDAR can be very useful to detect that object, tells us the distance, and that can activate a mechanism to avoid it. And that's why primarily the LiDAR is very good for our location as well as obstacle avoidance. So this image right here is the mapping tool as is represented by Robo Studio software. This dot right here would be us, the LiDAR, in place, and we can set up coordinates everywhere for if we want to keep track of an object or if we want to keep track of ourselves. We can also build virtual walls for training purposes, and the example right here uses a wooden box to keep track of that. Conclusion and future plans. Overall, we determined that the RP LiDAR, the one by SlamTech, gives us a really good range of detection for what we need. It works for the purposes that we need it, and it's good enough that it can be used in the model vehicle, but also it could possibly be used in a full-scale prototype. Also, since the research got cut short because of current events, we know we need further research for aspects of the LiDAR, such as the maximum travel speed that the LiDAR can handle to provide accurate data. That is a big concern because it is a race and we need to go faster than other vehicles. So its speed and how fast it can keep track of that data as we move is very important. And lastly, we need a good future plan for our algorithm for data interpretation. I mentioned earlier, LiDAR data is really hard to interpret overall. So we have to build an algorithm that can interpret that LiDAR data, and it can be used to communicate with different navigation algorithms. So we know something comes in, the LiDAR detects it, takes the data, send it to another algorithm that controls the steering, and that can avoid that obstacle. So those are what we need to do in order to finally complete this project and finally work with the LiDAR. Thank you.